again, let's say the values are 10, 11, and 12. And C equals now, let's say it puts it at address 3000. Means that the value of C here is 3000, which we draw as an arrow, a pointer. We're going to talk about two different operators in C on pointers. So we have the star operator on, let's say, some P, and that means dereference. Okay. So if P must be a pointer, type must be something star, and star P means follow the pointer and get the value that's pointed to. So it's following the pointer. And then we have ampersand A, let's say, and that is the reference operator. This evaluates to the address of A. So if A is an int, the type of ampersand A is 1. Yeah, how would you say that in C? In star. Okay? Questions so far? All right, so let's look at using these. I'm going to write down 3 things. First of all, 2 of them we did last class, which is review. So what if I say here B and here C? Discuss this, determine what is the value of B, what is the value of C. Not sure. A lot. So keep your hand up. Okay, so look at someone who doesn't have their hand up and ask them to explain it to you. Let's see if we can get by talking to each other. Not if people are talking here. See if you can remember what this means. This one is a little bit easier, so you start on this one.
My friend. Yeah, there's like a question that's like it's because I can't figure out like what they make it, they make this question and then or something like that. But like she's a point, so I don't know what that is. Right, what do you access to? It's not in the right.
Okay, so what is, let's start with the second one. What is the value of C? It says 3000. Who says something else? Okay, so that's good. Now, I said this is easier because, the value of variables always, if you draw a box, it represents what's in memory at the address where the variable is. That parses. The value of the variable is what's inside the box. You can see here that what's inside the box at C is the number 3000. And we could also say, using this syntax, that that's equal to the address of C sub 0. If there's C sub 0, C sub 0 is at 3000. In other words, it's the base address of the array. The address of the first element of the array is the base address of the array. Does that make sense? Okay, so what about B? There's no box. Why is it 2,000? Right. So to preserve this property, that when you write a variable that could be an array, without the dereference operator, or without the square brackets, what you get is the base address, you have to get 2,000. So this is equal to the address B sub 0. So it's not obvious. This one, C is a variable, so it's just like a normal thing. Here, B is not a variable, is it? What is it? It's a constant. It's a constant. Like the compiler picked at it, it's a number. There's no box that stores 2,000. It's just a constant compiler number. But in C, you can refer to it as a variable, so long as you don't try to change its value. So you can't change the value of B, because there's no box to store that in. You can change the value of C anytime you like. So this 3,000 is dynamic. It might not always be 3,000, it just happens to be this case. But the value of B always will be 2,000. Cannot be changed. Does this make sense? Questions about this? Yes?
There would be a time where you want to get, when you want to get 2,000 for B.
So the question is, would there ever be a time when you want to know the base address of an array? Sure. Just like you might want to know the base address of C. Yeah, so let's now talk about this. What is star B star C? Remember, star is the dereference operator. Discuss that with each other.
Dereference, whatever she's Oh, 10, right. That's a 10 out of 15. How do you do that?
Okay, so star B is what? Who's not sure? Okay, keep talking. You have to, so raise your hand if you're not sure. Look around, keep them up. There's people behind you that are sure. Ask them. You guys. Talk to somebody who didn't raise their hand.
What is star B equal to? I think it would be like leave first term, I think. Right, but B is not instantiated as a pointer. What is dereferencing something that isn't pointed? We could dereference any what is the dereference of A is equal to 3. What is dereference?
Okay, so let's take the first one, B. Star B means, okay, B is B. What's the type of B, first of all? No. In star, right, it's the address of B sub 0. The type of B sub 0 is int. If you take the address of something, remember I said it's that type of star. So the address of B is int star. So now I'm going to follow that pointer and get the value that it points to, and the type of star B will be what? Int. And what is the number? Well, I'll follow this pointer to go to that address. The question is, what's in memory? What integer is in memory starting at address 2000? The answer is 10. What's another way to write that? so same thing here, what's star C? 10, and that's the same thing as C. So I take, what is the value of C? 3,000, I follow the pointer, I read what's there, that's it. That makes sense? Question? Okay, so this one is a little bit stranger. What is the address of B and the address of C? This one is strange. Be sure you can get this and we'll talk about this.
Are we in C or in Java? How do you compare that? Right, yeah. I guess we don't know at this point.
Okay, so we say we want the address of a variable. You go to the box that's the variable, and then let's see where it is. Right? So here's C. Where is it? 2,000. And we can also do this now. We can say, what is star ampersand C? Well, so now I'm just gonna, I have now, what do I have? I have 2,000, I want to dereference it. So I'm saying, well, what's in memory at 2,000? 3,000, exactly. So it's the same thing as that, so that you can see they cancel each other out, which kind of makes sense, right? Because we're going to get the reference and we're going to follow the reference. How about this one? That's star ampersand C. Now you get a sense of what the midterm exam questions are going to be. I'm sort of joking. So what is that? 10, yeah. Right? Well, one thing we can do is we can just take that part, see that's that, or it just cancels out. It's the same as star. And that's always going to be true as long as you do the ampersand first and star ampersand together cancel out. You can't star everything, so if you flip it around, you might. You can ampersand anything. Any questions about that? Okay, so what about this? What is the address of B? And why is that weird? Yeah, either one.
Gonna be something to compile it, so.
Yeah, so the only thing that has an address are things in memory. B is a constant. It's not, there's no box for B. So actually B has no address. But in order to keep the symmetry between these two things, it's sort of like what happens here. C will give you a value for this. It's just weird. And it's like one of the least weird things that we're going to learn about C. Okay? So these two things, a static array and a pointer to an integer, are in the syntax of the language treated the same, except that the address of a static array is a constant. But otherwise they're treated the same. We use the same syntax, either that or that, to access elements of the array. We can use the same syntax to get the base address of the array should we want it. And we can also get the address of either. Although getting the address of the constant is sort of this arbitrary choice. Now you know, so questions about that? So you know that we can do something like this. So let's just look at C sub 2. What is C sub 2? 12. And we know from over there that C sub 0 is the same thing as star C. So want to say now star C plus something is the same thing as C sub 2. That makes sense? So just like I said here, C sub 0 is the same as star C. Here I want to say C sub 2 is the same as star C plus something. I want you to discuss for a minute what you think should be there. That's C.
Or the address of
12 is at 3,000.
yeah. So then O plus A.
Right, that's what it says as well. Address plus index times the size of the array.
All right, so we're going to add some number to C, and then dereference that pointer. What should we add? There's two obvious choices, I think. I think I heard one. What else? What are 8? It says 8. Why 8? Well, we can ask the question, what is the address of B sub 2? Sorry, C sub 2. So what is the address of C sub 2? Well, the address of C sub 0 is 3,000. C sub 1 is 3,004. The address of C sub 2 is 3008. And the address of C sub 0 is 3000. And so the offset, the distance between those two is 8 bytes. So therefore, you might think incorrectly, you should add 8. But that's actually wrong. What do you think it is then?
I think it's 2.
It's 2. Very good. Totally bizarre. But it's 2. So when you add a number to a pointer, you're adding in index space, not in offset space. Now, this is a little bit of an arbitrary decision in C, although if we did it this other way, where you added in byte space, then you could, if it was this other way, and I said this, if I said this, star C plus 2, and that was dereference the number 3002. What's wrong with that? It's in between bytes, it's not aligned. Everything's wrong with that. Right? This is like half of this one and half of that one. And even in C, the idea of doing that is viewed as being not that useful. Now, you can force C to do things like this by just casting the pointer to char, which is a single byte, and then you can get this stuff. Cast it back. But the decision in C was to allow you to use the dereferencing syntax for arrays in is to sort of substitute for the square bracket syntax and to do it in an analogous way. So since, if I say C bracket 2, the idea here is to say star C plus 2. So in general, for any array, C sub I, that's going to be equal to star C plus I. Just add an index. And you just kind of remember that. It's a little bit weird, but. So this means that if we were to write down the numbers here, we say the address of C plus I, well, that's going to be C, but I'm going to cast this now to an int. So just say make that an integer, because I just want to talk about it as a number. Adding I times 4. Which you can see on this slide here, this is how we go from offset space to index space. So by making this an integer, now I'm just doing regular math. Regular math would just be offset, so you have to multiply by 4. But if it's a pointer, then when you add, it's different. We're adding an index space. So it does that times 4 automatically, just like it did for array. So this is just showing you access to an array, the 7th element of an array, using square bracket, and access using the star syntax, again, the number 7 in both places. And in the assembly language and in the RTL, there's this point in which what we have is an index in an array, and then we use a load instruction that does the scale. And that's what's happening. Does that make sense? Questions about that? Okay, so final thing here. What is this? Discuss that.
Yeah, but none of us can all do it wrong.
Well, so the address of C sub 2 is what number? 3008. The address of C sub 0 is 3000. And 3008 minus 3000 is 8. So what's that? It's not 8. And I can prove it to you based upon this. So this decision here requires that this be 2. So when you're subtracting, you're also, if they're 2 pointers, and they have to be 2 pointers of the same type, actually. When you subtract them, what you get is the difference in index space. So it's the offset divided by the sign. And why must that be true? Well, I can just switch these 2 things right here into the star syntax. Okay? So I'll have the address of star C plus 2 minus the address of star, we'll just do C plus 0. Does that make sense? And then I can remove these parentheses here, so I can just say address star C plus 2 minus address star C plus 0. dress star, what is that? Address and star together cancel each other out. If I take the address and I dereference it, or dereference and get the address, so here I would be C going into C and then going back. So that is the same thing as this. And now the only sensible next step is this, C minus C plus 2 minus 0, which surely is 2. So in order for the math to be internally consistent, we have these two things, and they both turn out to be, there was this question earlier about why do you even need to know the base address? And in C, we're often manipulating pointers directly. And so it's often useful to make subtractions of things to find out how many indexes there are between them and to use that in some way. Some C programs are written to use arrays without the star, without the square brackets. I wouldn't recommend that, and later we'll talk about trade-offs between these two things. But sometimes that happens. So in fact, you don't need the square brackets for arrays. You can always use the star syntax. But if it's actually an array, then you probably should use the square bracket syntax, because that conveys more information to the reader of your code. But we sort of got into this because that might be a pointer to an integer. And it might be a dynamic array. And now you can see in C, there's absolutely no difference. Arrays and pointers are the same. If you have a pointer, you can add things to it. What you're adding is indexes, and use the star. But if you think it's an array, well, you can just use the square bracket, and you have indexes, but if you have a 0 as the index, it's just like a pointer. Does this make sense? Who does not think this makes sense? Yeah, no, it doesn't make sense, but it's the way it is. So there's now a question here. This just summarizes what I've said. This question is on Socrates, so I'm just going to go with that. Again, the room is 59, Feely, 5950. And I just want to explain, this is a slightly weird question. So what you have here is a piece of C, and what it's doing is we're looking at the thing that's circled in red. And what it's doing is it's reading something from memory and copying that into a location in memory. And what I'm asking you to determine is what is being read and what is being written. Thinking about it in terms of that was Java. Now in Java, you wouldn't be able to do the line above it. So just draw a picture of this array, C, and then indicate what's being read and what's being written. And then describe that in terms of the Java. Room number, sorry. Feely 5950. Yeah, you have to pay attention to the line above it, right? So this, we're looking at these two lines. And then what is the result of the second? Five seconds. 4, 3, 2, 1. All right. Well, it's kind of a weird question. So let's, maybe you said A, and you actually understood what was happening. Or maybe you didn't. So let's draw the picture here of what this looks like. So again, it's just this thing, right? So I have the array, dynamic array. C is a pointer to the array. So let's say that the array starts at 3,000. And so this is essentially the C sub 0, C sub 1, 2, 3, 4, 5, C sub 6. And the whole point of this question is that actually really, I mean, that is only true if the value of C is 3,000, and therefore this point's here. Because the meaning of these things, by putting that variable C, you're actually referring back to the base address. Okay. But the very first line, what does it do? It says C equals the address of C sub 3. So this changes C to point here, changing the value of C, what's in that, to what? What's the address of C sub 3?